right, today we're talking about adding and subtracting integers. We're going to use a number line and integer chips to help us understand what happens when we combine the positive and negative numbers. I want you to explain your thinking, listen to each other, and build on each other ideas. This is discussion. It is not a race. All right. The task for today. Our problem is a negative 2 plus 5. So can everyone write a negative 2 plus 5 on their desk? Okay, I have two students that are going to be doing using the integer chip strategy and two students that are going to be using the number line. One will use number line, the other will use integer chips. We're going to discuss both strategies, and then you will show me a third method. All right, I'm gonna give you guys about 15 to 20 seconds to solve your problem. So can you start now working with your strategy chips and your number line to start your problem? You can start now. Start now. Okay. Now, the number line discussion. Who can start off by explaining how the number line works for a negative 2 plus 5? Ms. Williams?
You start with -2 when that's your first number on the equation. So you're gonna start with -2, and then the second number of the equation is 5. So you're gonna hop 5. So it's gonna start off 1, 2, 3, 4, 5, and you landed on 3. So your answer is 3.
Okay. So you're saying that started at a negative 2 and you move 5 spaces to the right because adding a positive number means moving in a positive direction.
Yes.
Did I understand you correctly?
Yes.
Okay. Who can add on to what was just said? Yes, Ms. Johnson?
So that the number line works very well because that you have to start at your negative number and then you go up and you do 5 loops and the 5 loops will land you to 3. And it's another strategy that also is known. It's actually it's like addition. It's for like 3 plus 2 equals.
So, you're basically saying that, let me get this understanding right. So, why do we move right instead of to the left? Why do we move right instead of to the left?
The left is negative and the right is positive.
So, why then are we moving to the right?
Because that the 5 is a positive number.
Okay, so you're saying that you're moving to the right because 5 is a positive. So basically, when you starting at the negative 2, you move 5 spaces to the right. Is that correct? So what do you notice about crossing 0 on the number line?
It is a positive number.
Yes. So when you cross 0 on the number line, that means you are going into the positive direction. You are absolutely correct. So now let's talk about the integer chip strategy. Tell me about the integer chip strategy. The students use 2 red chips for -2 and 5 yellow chips for 5. Who can explain what happens when we mix the red and the yellow chips?
When we mix the red and the yellow chips, it becomes a 0 pair.
It becomes a zero pairs. So you're saying when the red and yellow chips create zero pairs, is that correct?
Yes.
So who can explain what a zero pair is in your own words?
A zero pair is like when one and one cancel out each other and it turns into a zero because there's nothing left.
Okay, so you're saying that when a positive chip, which is the yellow chip, and a red chip mix together, they cancel out. Okay, is that correct? Is she correct?
Yes.
All right, so once we cancel out the zero pairs, what chips are left?
3 positive chips.
Okay, and what does that tell us about the answer?
The answer is positive 3.
The answer will be positive 3. Why do you know it's a positive 3 and not a negative 3? Yes, Tiara.
Because the 3 is not negative, it's positive.
Okay, so who else can explain with using the integer chips strategy?
Because there are 3 positive chips left.
Yes, there are 3 positive chips left. So is there any negative chips left?
No.
So that's let you know that the answer will be what?
Positive.
A positive number. Who can connect the chip method to the number line method? Who can connect the chip method to the number line method?
They both create negative. They both create 0 pairs.
Yes, they both create 0 pairs. So they create 0 pairs by when you're moving, like with the number line, you're moving places to the right. So each time you're moving to the right and you're starting at a -2, when you move to the right, you're adding a what?
1.
You're adding a positive or a negative? Which one?
Positive.
You're adding a positive because you're moving to the right. So that's the same thing you're doing with the number chips. When you put these 2 pairs together, you're canceling it out. When you move to the right, you are canceling out the negative, and that's why the negative gets smaller. All right? So I want you guys to do a third method, and I want you to work in pairs doing this third method. All right? I want someone to show a third method. You can use mental math, breaking apart numbers, or drawing a picture. All right? So this next strategy, I'm gonna give you about 15 seconds, and I want you to do mental math, drawing pictures, or whatever it takes to get you to solve the answer. Just come up with the third method. All right, who can come up with the strategy they use? Bernicia? Yes.
A strategy that I use is because I take the bigger number and put it on the other side. I swap them because 2 is a smaller number. So it's easier and simpler that way. So 5 minus 2 would equal 3.
Okay, so you kind of did the reverse. Instead of making it an addition problem, you made it a subtraction problem. And that's how you came up with the positive 3. So is that a mental math or drawing pictures, or which method did you use?
Mental math.
Yes. So she did the mental math strategy. Because she knew that 5 was bigger, she went ahead and made 5 the positive, because it's going into the positive, and she made it a subtraction problem. So you still have the positive 5 and you still have the -2, because she made a subtraction problem and she still got the same answer. All right, what's another strategy? Let's see. Miss Brigham did something. What did you do, Miss Brigham?
I drew 5 positive x's and 2 negative x's, and I crossed out the one negative x and one positive x, and another negative x and a positive x, and I had 3 positive x's left.
Okay, so which strategy did she use? Was it mental math, pictures, Which one is you? Pictures.
Pictures.
So, with the third method of doing the strategies out of the three that you did, which did you find this problem to be easier or was it a little confusing?
It was easier.
Easier. So you're saying that you understand it now a little bit better than what it was before, or is it 1 to 4? Let's rate the level of how well do you understand this lesson.
4.
4. Who can explain why they think it's a 4?
Because this is like a simpler and easier way, and I could see exactly how it's worked out and understand it.
Okay, Justin, what you want to say?
That it's more easier to solve with the subtraction 5 minus 2 because it actually helps with people with subtraction.
Okay. Does anybody have anything else to add? All right. So, do all three methods give the same answer?
Yes.
And why does that make sense? Why does it make sense?
Because it's simpler and easier, and it shows us how.
So it gives y'all a visual.
Yes.
It gives you a visual understanding of learning negative and positive integers.
Yes.
Okay, before we end, I want someone to summarize this in a sentence for me. Just summarize in a quick sentence what we learned today.
You could use visuals to learn how to do positive and negative integers.
Okay, do anyone want to add into what she said?
You can use different strategies to help you understand the problem better.
Okay, and you was working with what today?
Positive and negative integers.
Okay, so when you add a positive and positive number to a negative number, the answer depends on which number has the what value? The largest
value.
or the greater value. Great job. All right, thank you. That's it.